Hi guys, so hopefully you are currently just finished up talking about the International Space Station and weightlessness and orbits and all that jazz, and I'm going to give you a couple notes on gravitation and then you're going to go back and do another activity. So let's talk about gravitation. What is pulling on you gravitationally right now? Like what object is pulling on you right now? So go ahead and answer that question for me. Hopefully most of you said the Earth, right? And it turns out anything that has mass is pulling on you. Anything that has matter is pulling on you gravitationally right now. So that includes your desk, the person sitting next to you, the classroom, the ceiling, your best friend in a completely different room, the moon, Jupiter, anything that has mass is pulling on you gravitationally right now. So if you think about it, gravity can be thought of as a very romantic concept because at this very moment you're being gravitationally pulled towards that special someone you're interested in. So I think this is like the ideal way for someone to ask someone to prom. But you would say, excuse me, but I'm really attracted to you, and according to Newton's law of gravitation, you're attracted to me too, right? So I think you guys should all, AP Physics whizzes, ask people to prom using gravitation. So what does that mean? If any two objects with mass feel a force pulling them towards each other, then why do you only feel like you're currently being pulled down towards Earth? Why don't you feel like you're being pulled towards the person next to you or towards the ceiling? Why don't you feel the effects of that in your everyday life? Well, it turns out gravity is a very, 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 very wimpy force. Out of the four fundamental forces, gravity is the weakest of all of them. So we don't see its effects until we get to larger scale things. So if we think about why do we feel it on Earth then? And why do we feel it on the moon? And why do we feel us orbiting around the sun? Well, that turns out because the mass is huge for the Earth. Mass of the Earth is 5.98 times 10 to the 24th kilograms. That's a massive number. I don't even know how to pronounce that number. It's like septillion or something. Okay, so it's a lot of mass on the Earth, so we see the effect of it a lot more, whereas the average person sitting next to you is only about 70 kilograms, so you don't feel the gravitational force of that person sitting next to you. All right, so this is just the general ideas of gravitation. What you're going to do now is go work on the inertial mass versus gravitational mass activity. Watch some videos on that and answer some questions there. So it turns out I'm being gravitationally pulled towards Peyton right here too. Peyton, say hi. Look over here. You say hi to everybody? Yeah. Gravity? Do you like learning about physics? All right, guys. Next activity is inertia. I'll see you in a few minutes. Bye.